Good morning, ladies and gentlemen. Welcome to Systems by Kumsin. Today we are going to be learning about database indexing. Now, before we delve right into it, let me ask you something. So, if I give you a book to find a particular chapter, what's the first thing you're going to do? You obviously are not going to start reading from the very first page, reading everything in order to find the particular verse that I've asked you to find. What you're going to do is go straight to the table of content, find the exact page to where the chapter is, and then you locate where the chapter is. The ability to jump directly to whatever you are looking for is exactly what database indexes does. So now let's bring it to software engineering or system design. Now, every application out there in production uses or stores their data in a database. They store records like users, transactions, messages, emails, and many more you can think of. So imagine your database has about 1 million records and you want to find just one. Without any structure, without any shortcuts, the database is going to search the entire table, and this is what we call a full table scan. So with a full table scan, the database starts from the first row down to the next. If it doesn't find it, it moves on till it reaches or finds the exact point or the exact position to the data you are looking for. At small scale, you're not going to notice this, but when your system begins to scale, that is when your system will begin to slow down. So instead of searching blindly, we introduce a structure. We introduce a structure that will tell the database exactly where to go or exactly what to look for. That structure is called an index. So the actual definition is an index is a data structure that helps a database to find data quickly without scanning the entire table. So let's think about the Bible for a second. If you're being asked to find a particular verse, you don't start from Genesis, reading through Exodus, you know, to Revelations in order to find the exact verse you've been asked to look for. You go to the table of content, you find the book, you find the chapter, you find the verse, and then you are good to go. Right? That hierarchy, that organization is what makes searching of records faster. So this is how indexing works in a database. Also, indexes are stored in a structure called a B tree. So think of it like a tree structure. Instead of checking every row, the database starts at the top, it makes a decision, it moves down the branch, it narrows the search step by step until it finds exactly what it needs. So instead of searching 1 million rows, it might only take a few steps to locate the exact record you are looking for. That's how powerful indexing is. So now we want to compare the two, with and without indexing. So without indexing, the database would have to search the entire table that's called the full table scan. And then with indexing, the database knows exactly where to find that record without scanning the entire table. So now let's delve into some of the types of indexing that we have. So we have what we call the primary index. This is created automatically. It's actually based on your primary key and it uniquely identifies each row. The second one we have is a secondary index. This is where you as an engineer makes decisions and you create indexes on fields you search often, like email in a login system. We also have the composite index. This is an index built on multiple fields. For example, first name plus the last name. And here, when you want to use a composite index, here the order really matters because name and age is not the same as age and name. So you need to get that right. Yes, we also have the unique index. This ensures no duplicate values. So two users cannot have the same email in your system. If that happens, then that is a major error. Now here's where things really get interesting. Indexing are very powerful, but they are not for free. What do I mean? Every time you insert or update or delete data, the index must also be updated. When that happens, your writes becomes slow. And we also have what we call the storage cost. We also need to consider the storage cost when we talking about indexing. Indexing takes a lot of space. So as an engineer, your duty is not to add indexing everywhere in your system or in your database. What you want to do is to add them strategically. So I'm going to walk you through when to use indexing and when not to use indexing. So when to use indexing, use indexing when your data is large, when you query frequently, when you need fast reads, and when not to use index. Avoid indexing when data is small, when queries are rare, and when your system is write heavy. So before we move on, you probably heard of write You've probably heard me say reads. So let me just give you the clear difference. So writes and reads are fundamental operations for handling data in computing. Write saves or records information to a storage medium, whilst reading retrieves or access that stored data. So that's the comparison between the two. So now let's take something simple like a login system. Let's say you want to find a user by email. Without indexing, the database would have to search the entire table in order to find that particular user with a certain email, because emails are unique. And with indexing, it jumps straight to the correct user. So that is why login fails instant a lot of times in most applications or systems. Now, there are some common mistakes that most engineers find themselves doing, and I'm going to list a few. One is adding too many indexes, indexing the wrong fields, ignoring write performance, and this can lead to new performance problems. So now, anytime you are building a system, you don't want your database to search blindly. And so what do you want to do? You want to introduce what we call the database indexing to allow your database point to the exact position of the particular data you want to retrieve or search for. So without indexing, your database will just search blindly. But with indexing, your database knows exactly where to go in order to find the particular data you are searching for. So this is a short teaching on database indexing. Thank you for watching. Don't forget to like, subscribe, and share. Leave a comment below, and I'll see you in the next video.